Welcome to the lecture on special sand molding processes. So, in this lecture we will discuss about the processes of molding and core making based on inorganic binders. So far we have studied the use of clay, which is also an inorganic binder for molding and core making, but apart from clay, as the technology have advanced and depending upon the drawbacks of the clay system, there has been different types of inorganic binders which have been proved to be very effective in molding and core making towards improving the productivity. So, in this lecture we will discuss about the processes of molding and core making based on inorganic binders. So, what we have so far studied, then we have seen that special molding processes are required to be developed, which require less skill, because in the case of molding or core making, in core making anyway we do not use the clay, but in molding where we use the clay you need a person with good skill, and also the rate is not so fast. So, and the effort is quite high. So, you need to have processes where less skill is required, because the main problem is related to the hardening process. So, in the case of clay as binders, you need to mix the clay properly and then you need to bake it, you need to dry it, and that requires time. You have to use many other means to dry it so that it develops optimum strength. So, in that case more skillful labors are required for basically the removal of the pattern from the mold or for baking it. So, you need to have those methods where with less skill you can have a better processes which gives you save of time and you are getting better quality of molds and cores. So, this way the productivity will be improved. Now, in these cases we aim that the need of baking or drying should be eliminated, because most of the time is spent on baking and drying, and if the baking or drying is not proper, that leads also to many kinds of defects. So, if you can devise those binders or that system where you can avoid this baking or drying by heating mechanism or in other way, in that case it will be better. So, in these processes you avoid the need of drying or baking, and the hardening will take place mainly due to the chemical reaction. So, that processes we will see later in the later slides, and these processes can be based on either inorganic binders or organic binders. So, and there are also special processes that we will discuss even later on. So, first of all we are going to discuss about those processes which use the sodium silicate as a binder. Now, use of sodium silicate as binder has increased considerably in recent years. So, sodium silicate has found to be a very useful material as far as the binding material is concerned. Here mold and cores do not need drying or baking and in some cases not even ramming. So, this way, because we will see different processes where sodium silicate is used as binder and you do not need for the drying or baking of the mold or core, and even not ramming by use of certain chemicals, foaming chemicals, sometimes even ramming is not required. The flowability of the molding material is such that it automatically goes into all the portions like a fluid, and so ramming is not even required, you get the hardened mold or core. Different types of hardeners and catalysts are used, and that signifies different kinds of processes where the same binder, that is sodium silicate, is used. So, we will discuss about those different processes, and this can be applied for ferrous as well as non ferrous castings. So, let us go to the first process which is most versatile, which is mostly used in medium and large scale foundries, even in small scale foundries, and that is carbon dioxide process. So, it is also known as CO2 process of moulding or CO2 moulding process. So, why it is known as CO2 moulding process? Because in this case, as we know, we are discussing about that system which uses the sodium silicate as the binder. So, binder is fixed, but then CO2 works as the hardener. So, CO2 gas is passed through the sand mixed with the binder, and once it is passed, it automatically gets hardened in a very short amount of time. So, immediate hardening takes place because of reaction between sodium silicate and carbon dioxide. So, what happens, the CO2 in the case of this carbon dioxide process, the sodium silicate will react with carbon dioxide and it forms a hard spongy mass basically, and this formation or this action of cohesiveness or the strength is because of the formation of a reaction product that is known as silica gel. So, this silica gel is responsible for giving the strength. So, if you look at the reaction, what happens that in the case of CO2 moulding, you have the sodium silicate. So, sodium silicate is nothing but Na2O MSiO2 XS2O, and this reacts with CO2. So, that makes Na2CO3 plus MSiO2 XS2. So, this reaction takes place, and this reaction taking place, basically this is known as silica gel. So, this silica gel is basically responsible for giving you that strength. So, that binds, and as soon as the carbon dioxide is passed through it, the hardening starts taking place. So, even if you leave this mold in the open atmosphere, it picks up the carbon dioxide from the atmosphere and slowly it will harden, but to save time we pass through torch or with some other mechanism the gases through it, and the reaction takes place and the hardening takes place. Now, in the case of this sodium silicate, there are two things important. One is mass ratio and specific gravity. So, mass ratio is nothing but the ratio of Na2O is to SiO2. So, this ratio is known as mass ratio, or its inverse is known as the molar ratio. So, this mass ratio or the specific gravity that talks about the property of particular sodium silicate. So, specific gravity is also somewhere close to 1.5 is maintained, 1.3 to 1.35, or sometimes in certain processes we even use of 1.5. So, that we will discuss later. So, what is the process? The process is that sand mix, that is sand plus 3 to 5% sodium silicate by the weight of sand. So, in the sand we are mixing 3 to 5% of sodium silicate, whose specific gravity should be 1.55 to 1.71. In this case, we are keeping the specific gravity from 1.55 to 1.71. So, basically the specific gravity depends upon the mass ratio and the amount of water which is present. So, the mass ratio again further can be altered by suitable addition of NaOH. So, if you want to change the mass ratio, so mass ratio is nothing but this ratio Na2O to SiO2. So, it is nothing but this is ratio of total alkalinity to total soluble silica. So, this is known as mass ratio, and its inverse is known as the molar mass. So, basically you can change this, increase this by adding NaOH. So, this way you can change it, and even the gravity, specific gravity can be changed, because that basically is a function of mass ratio and water. So, this way specific gravity can be altered somewhat, and it has to be kept in certain limit while using. Further, you can also change the even the mass ratio or the gravity. So, sometimes we use certain agents to change these characteristics of this sodium silicate by using certain additives like invert sugar. Now, additives also are used like dextrine, C-coal, corn flour, iron oxide, invert sugar. These are the additives which are basically required to increase the collapsible property of the mold. One of the drawback of this carbon dioxide moulding is that the collapsibility is quite poor. So, in that case we use certain additives, and these additives are like this, and to improve the temperature properties like hot strength or so, you use this iron oxide. The invert sugar, it is also a breakdown agent. So, basically it also increases the collapsibility of this mold, where we use the carbon dioxide to harden it. So, it is basically used with certain proprietary agent or proprietary compound, and then it is used in that mixture, so that the collapsibility is increased. Now, carbon dioxide has to be passed for predetermined length of time. So, what happens? Carbon dioxide, once you pass, it has to be passed for certain amount and for certain time, and as a time is reached, you will have certain optimum strength. After that, basically the strength decreases. So, there must be a predetermined length of time up to which this mold should be gassed. So, this carbon dioxide should be allowed to pass through the mold. On an average, 1 kg of sodium silicate requires 0.5 to 0.75 kg of gas required. So, this is the typical composition of sand plus sodium silicate, and based on, once you know the sodium silicate, you know that how much gas is required to be blown into, and that way that much gas can be allowed to pass through the mold by placing the nozzles at different locations and allowing the gas to pass through it. It has also been seen that if you allow the gas to pass through at a slower rate, the hardening is better than the case when you allow the gas to pass through it at a fast rate. So, you should try to maintain an optimum rate of even flow of the carbon dioxide gas through the mold. Now, what are the advantages of this process? So, before that, when we are talking about the gasification of this mold, in that case basically you have certain drawing rate of the gas, and this drawing rate of the gas depending upon the vaporizing ability of the gas. So, drawing rate can further be increased by using these vaporizing agents or so. Now, advantages of this process are many, and among them you have saving in labor. What happens in this process? What you see is, in other case you will have to mix the sand with clay and binder properly. Here also you mix with sodium silicate, but then simply you pass the gas through it. So, there is not much of skill is involved, there is not much of labor is involved. So, labor and skill are basically quite less involved. In this case, what happens, since you are withdrawing the pattern, because the baking is instantaneous, as you pass the carbon dioxide gas through it, the baking takes place. So, since the baking takes place, in that case the withdrawal of the pattern is better. So, withdrawal of a pattern becomes easy. You need lower level of skill in this case as compared to that in the case of other processes like using clay as the binder. Accuracy and finish is quite good in this case, because you can use, you can have, that while taking the pattern out is not much of problem. You can control the sand grains and you can get adequate strength. So, because here in this case you get adequate strength and the mold stability is quite okay. So, in that case your finish is quite okay in these cases. So, they are basically used for different kind of castings, mostly for small, medium and large scale castings use this type of processes in industries. All the automobile parts are basically manufactured nowadays using this carbon dioxide moulding processes if they use the inorganic binders. Now, the next process where the sodium silicate binder is used is the ferro-silicon process. So, in the ferro-silicon process what happens, the sand is hardened and bonded with reaction product obtained by exothermic reaction between sodium silicate and ferro-silicon powder. So, what happens here? Here we do not use the carbon dioxide gas to pass through it. So, what happens here? Here actually we use this ferro-silicon powder. So, once this ferro-silicon powder is used, this reacts with this sodium silicate, and this reaction is a exothermic reaction, and in that reaction you have the release of hydrogen, and because of this exothermic reaction the temperature is increased, and temperature is increased to the level of about 90 degrees C. So, once the temperature is increased, at that time normally the boiling takes place, near boiling takes place in the mixture, and this due to this boiling the foaming takes place. So, what happens due to that, basically the sand has quite a good flowable property and it goes into all the portions of the mold and then it hardens. So, this is the point to be noted in this ferro-silicon process. So, here also you have binder as sodium silicate. Sodium silicate and ferro-silicon powder is taken in the ratio of 2.25:1, and this reaction continues till silicon and water are present. So, as long as silicon and water is present, the reaction goes on, and as since the temperature is increased, the water vapor is dispelled off. If the excess of water is there, all the water is dispelled by decomposition and evaporation. So, basically that is dispelled off because of the decomposition and evaporation. So, what we do is, as the temperature is increased, reaction rate increases and hard spongy mass is formed. So, as the temperature will increase, a hard spongy mass is formed and that basically strengthens the mold. So, in this case no baking is required, no passing of any gas is required, it automatically gets baked up and automatically it gets a large strength. So, in this case what we do is, sand will be added with 2% ferro-silicon, which has 80% of silicon in that ferro-silicon, which is powdered to 2 to 3 micron size. So, ferro-silicon powder is there which is about 2 to 3 micron size, quite small size particles are there, plus 5% sodium silicate is used, whose specific gravity is seen to be maintained around close to 1.3 to 1.35. So, this way you can have the sodium silicate, basically you can use the invert sugar to change the specific gravity by without changing the mass ratio of the sodium silicate. So, once you do that, then reaction takes place and slowly once the reaction if you increase the temperature, the reaction will be at faster rate, but even at normal temperature it will go on, because it is an exothermic reaction. So, temperature will certainly be increased. Now, in this case also additives can be added to impart specific properties like collapsibility and bench life. So, as we move, the bench life becomes shorter. As we had discussed, even in the case of carbon dioxide moulding, the bench life is a limitation. You cannot leave the mold which has been prepared by mixing the sand with sodium silicate in normal atmosphere. In the normal atmosphere itself, it will be baked or it will be dried in certain time and get a lot of strength. So, in this case also you have collapsibility as well as bench life. So, bench life is a problem in those cases because you cannot keep it for long. In this case again the bench life is shorter and there is a problem of collapsibility. So, for that we are using the different types of additives which should control the collapsibility as well as the bench life. Foaming agents are also used to increase the flowability of the slurry. So, certain foaming agents are used in that mix, so that flowability is further increased, and as we know you have a shorter bench life here, even shorter as compared to the CO2 moulding. So, you need to see that you are quickly using the sand mix to get the mold and the core. Next in the line is the process known as Dicalcium silicate process. So, what happens? It is also known as a fluid sand process. The sand mix is becoming fluid and it is given a name dicalcium silicate because dicalcium silicate basically it is obtained from slag of some of the melting or reduction process like hot blast cupola or furnaces, acid lined furnaces. All these places you get the slags. These slags are basically having adequate amount of dicalcium silicates. So, this dicalcium silicate is used as a fine powder. So, it is basically used as a hardening agent here. So, in case instead of using ferro-silicon, we are using the dicalcium silicate. Now, in the earlier case what we have seen is that when we use the ferro-silicon powder, the temperature was exothermic reaction. So, temperature increased, but in this case the temperature need not be increased. Once you mix this dicalcium silicate with sodium silicate, so what will happen? So, this dicalcium silicate is seen to be a good hardening agent with sodium silicate as binder. So, when sodium silicate is used as binder and dicalcium silicate is mixed, dicalcium silicate acts as a hardener. Rate of hardening depends on grain fineness of silicate. So, you have to have less than 200 mesh size of the dicalcium silicate, and also it will depend upon the temperature of sand. Higher the temperature, more and more quickly it will harden. So, that is there. So, the process is like this: you have a sand mix which is nothing but sand plus 2 to 3% of dicalcium silicate powders by the weight of the sand plus 5% by the weight of sand. You are using the sodium silicate plus suitable foaming chemicals. You are mixing for 3 minutes and it works as a slurry, as a moving slurry, at like a fluid. So, without going for any ramming, it goes into all the cavities, internal cavities, everywhere in all the corners it goes like a fluid sand, and that is why it is also known as a fluid sand process. Its bench life is about 25 to 30 minutes. So, here also bench life is short, you have to use it quickly. Sodium silicate which should be used must have a high mass ratio of about 1 is to 2.3 to 1 is to 2.8. Specific gravity should be maintained somewhere close to 1.5. So, this way you can have the control of sodium silicate which is used. It is used for medium and heavy ferrous castings. The next process is cement moulding process. Now, in this case Portland cement is used as a binder, and it has been seen that if the sodium silicate is used with Portland cement instead of water, if you use the sodium silicate you get better properties of the mold. So, that is known as cement moulding process. In that you have sand mix 2% cement plus 4.5% sodium silicate plus 1% pitch or molasses to give the specific property, and in this case you are getting the cement mold which has a bench life of about 15 to 20 minutes. You can use the foaming chemicals, so that ramming requirement is decreased, and the mold normally it is used for large molds, large size castings and good shake out properties. So, this way this cement moulding also, here you use the sodium silicate as binder with Portland cement, giving you a very good process for very large size castings. There is another process known as Chamotte process. So, this burnt fired clay which is also known as a Chamotte. So, that is basically used as a hardener with sodium silicate as binder. So, in that case high silica sand will be mixed with 4 to 5% of sodium silicate and 2% Chamotte is used. So, that basically gives a very good strength to the mold, and it is used for producing very heavy castings at low cost, free from defects like sand fusion, hot tears. So, this is mostly used for a very extremely large ferrous castings, and it has been seen that it gives a very good property at a very low cost, and the defects like sand fusion or hot tears are not seen. So, these are the different kinds of processes which are based on the use of inorganic binders and mainly the use of sodium silicate, these are which are mostly used, and these are the common methods which are used by small, medium and large scale foundries which have the edge. So, these processes have the edge over those processes where the clay as a binder is used because of its inherent advantages like low cost, less skill required, good surface finish, good accuracy and all that. In the next lecture we will discuss about the processes based on organic binders. Thank you.